Moving on to question 2. This is going to take 10 years to talk about, but alright, that's fine. We'll have all the time in the world. I'm going to try to do it in 10 minutes. Probably will need longer. Alright, so we have Tasmania Jones, our very first Tasmania Jones question of the year. And this time he is in the South American jungle. Oh my god. He's been walking to help the Quetzalcoatl. Is that even a real thing? I may look it up later. Tribe to get drinking water from the very salty water of the parabolic river. Okay, so this is your parabolic river. The river follows this curve with equation y. Can I round this? Yes, equal to x squared minus 1. So the domain is greater or equal to 0. I'm not sure if it's useful. All lengths are measured in kilometers. Not sure if that's useful either, but we'll see. Tasmania has his campsite at 0, 0. So they very highly labeled the diagram for you. And the village is at 0, 1. He builds a desalination plant which is connected to the village by a straight pipeline. So this is a desalination plant. Immediately I can tell that you probably would be able to rewrite this coordinate to m and m squared minus 1 because this point lies on the curve. Okay, so that's the desalination plant. If the desalination plant is at the point Mn, shows that the length, L kilometers, of the straight pipeline that carries the water from the desalination plant to the village is given by this. Alright, so this is a show that question. You need to show that the length of the pipeline, now this is a pipeline again, so helpful, giving you a fully labeled diagram. So basically you just need to show that the length of this line is whatever it was, it is in terms of m. So I think it was correct to convert this point to m and m squared minus 1 because you want everything to be in terms of m. So essentially what this is you need to show the distance. So L is the distance between 2 points. It's the distance between the one point is m and m squared minus 1 and the other is 0, 1. 3 marks, so I guess the first mark is to probably recognize that n equal to m squared minus 1. 0, 1. Okay, so L would have to equal to, now you want to show all working out because it's a show that question. The good thing about show that question is at least you know what the answer is supposed to be. So minus 1, minus 1. So, okay, so just say x1. It doesn't matter which one is which, as long as you're consistent. I'm going to expand the bracket. So m minus 0 squared is just m squared. Well, hang on, I'm just going to simplify first. So this is m squared minus 2 squared. For the love of everything holy, or everything math related, please do not expand this into m squared minus 4. That would be incorrect. If you don't know how to expand, actually even if you do know how to expand, it is a good practice to just check with the cat. So all we're going to do is we're going to type expand and then x squared minus 1 minus 2 all together squared. So this is what I want to expand. I get x to the power 4 minus 4x squared plus 4. People always make mistakes in this, and to be fair, you should have memorized this by now. But anyway, use the cast to your full advantage. Don't lose mass. You can definitely write m because of silly things like that. So if you expand that, you get m to the power 4 minus 4m squared plus 4. Okay, now this is looking really good because this is probably, I probably don't need that much space. And if you just simplify, you would have that equal to m to the power 4 minus 3m squared plus 4. And this is exactly what you need. So I think we've shown that. Okay, part B. If the desalination plant is built at the point of the river that is closest to the village, so I'm going to translate that to minimum stationary point, which means that it's going to be built at a point when the derivative of L equals to 0. There is no, okay, the slowest point is not always a stationary point, but I think we kind of need to, considering how it continues with asking you to find the derivative. Okay, find dl dm, and hence find the coordinates of the desalination plant. 3 marks. I think I know where the 3 marks are. I think 1 mark is going to be for finding dl dm, which means that I am not going to do it by hand. You can do it by hand. This is not impossible to do by hand, but we're better things to worry about. So I'm going to define. I feel I'm going to need this in the future. So define L of m equals to, oh, I'm going to use L of m because I really do want to show you one thing. So m to the power 4 minus 4m squared plus 3m squared plus 4. Can't remember things. Minus 3m squared plus 4. Okay, so that's that. So we're gonna find the derivative. So I'm gonna define dl, which is derivative of L of m. Now, if you're going to use a variable that is not x, when you find the derivative, you just need to make sure that you write m here. You're deriving in terms of m, not in terms of x, which sometimes people just forget because you know, you write x all the time. But if you do that and I just go dlm, then I would have that as my answer. Okay, so I'm gonna, maybe you don't have to, but I'm expanding the, okay, so 4m q minus 6m squared over the square root of m to the power 4 minus 3m squared plus 4. You could also do it by hand, it doesn't take long at all. So this is a derivative. I think the second mark is to actually find the m coordinates of the stationary point. So I'm going to solve for m when dl dm equals to 0. So I'm going to once again use a cast. If you want, you can write the equation out. So 4mq minus 6m squared over square root of m to the power 4 minus 3m squared plus 4 equal to 0. So I'm going to solve for m. Take full advantage of defining. Again, solving for m, not for x. You get 3 answers. Did I do something wrong? I feel like I've done something wrong. Actually, no, that's fine. Okay, so you have 3 answers, and you probably want to show all 3 answers in your working out. So I have m equals to plus or minus root 6 over 2 or 0. Okay, so 3 possible answers. The next thing, and I think this is where the third mark is, it's for working out which answer is going to give you a minimum. You can do anything you want, like you can show a side table because you have the cast, like it's not too hard. However, I'm not going to do it for all 3 answers. I know m can't be negative because it has to be greater or equal to 0 to lay on this curve. And I know m can't equal to 0 because, well, 0 is here. It doesn't look like it's going to be correct. Actually, it can equal 0, I don't know. I think the answer is going to be positive square root of 6 over 2, so I'm just going to start with that. It's probably a good opportunity to revise how to use the side table as a way to show that something is a minimum. So this is L. So we have positive 6 over 2. Don't pick 0 because that's just another stationary point. You want to pick something that's a little bit smaller than square root of 6 over 2. Maybe 1 will do. And I'll go with 3 over 2 here. So the LDM is 0. Now, this is a good thing of having a cast. You can substitute whatever value you want in. So DL of 1 is negative and DL of 1.5. I'll go 3 over 2. Is that? So definitely negative before and positive after. So less than 0 and greater than 0. Okay. So going down, this is L. I know it looks like a 2. Going down, 0 going up. So you definitely have minimum. All right, I just need to draw a line here so I have a little bit more room. Okay, so we definitely have local minimum at m equal to square root of 6 over 2. And just lastly, I'm going to just sketch it. Oh, I should have thought of this. I mean, if I can't sketch it now because that's in terms of m. It's not going to work. Can I change this to m? Yep. Okay, fine. In that case, I'm going to redefine it. Can I do that? I'm just going to trust it. Okay, so L of square root of 6. No, we shouldn't do that. Alright, so what I'm going to do, this is why you really should define in terms of x. I got square root of 7 over 2. I'm just going to write the answer down first. So L is square root. Actually, I don't need L. I want the coordinates. Okay, so if m is that, then n, it's going to be 6 over 4 minus 1. Which is that right? Why is that? Okay, yeah, no, it is right. Okay, it is a half. So the point is at square root of 6 over 2 and a half. And just because we want to check that this is actually the lowest point in the graph. Hi. Alright, fine. I'm doing this again. Define L of x. I think we'll be fine. It won't take too long. Well, just need to fix the variable so I could actually sketch. Before I forget again, I'm going to fix my derivative just in case I need it. So x. Okay, so we're gonna sketch. This doesn't work, so the L of x should work now. So that looks good. I think if I just analyze graph minimum, let's go from here to here. So minimum occur at that. Okay, so 1.22 square root of 6 over 2. Let's try square root of 6 divided by 2. Yep, looks good. Alright, so definitely the smallest point. Alright, so that's part I. The second part, find the length of the pipeline. I think I kind of already did that. Find the length. So this is where you find L. So if m equals to square root of 6 over 2, then L is it square root of 7 over 2, I think was the answer. Is it a Mach? How is that 2 Mach? L is L of square root of 6 over 2 is square root of 7. I'm trying to think where the second Mach would be. Yeah. But anyway, it seems a little bit redundant to actually ask you to show any more working out. So I'm gonna, so square root of 7 over 2 kilometer. That's the final answer. Maybe the unit is part of it. Okay. There you go. So that's that for part B. And then we have the fun part, which is part C, but let's just stop here and then we'll move on to part C in a bit.